Hi everyone, in this video we're going to go through 10D types of stationary points, but we're only going to focus on the end question in the notes, question 23. So as we went over in class, we can have three different types of stationary points. We can have a local maximum at A, and that just means as your gradient is increasing as it approaches A, the gradient at A is 0, so dy dx is 0 at A, and then it's decreasing again. Okay, and then we get to B, where dy dx is equal to 0, or your gradient function is equal to 0, and then we're increasing again. So we call both A and B turning points. So either side of the point, the stationary point, your gradient is different. So either increasing one side and decreasing on the other, or decreasing on one side and increasing on the other. C is also a stationary point, so dy dx also equals 0 at C, but it's increasing on one side and increasing on the other. So when your gradient is positive on both sides or negative on both sides, it's called a stationary point of inflection. And that's what is covered here. Okay, so you can have a look there. In class, I did show you how to test the gradient, so we're going to not focus just on that, but we're going to cover that again in this video. All right, so we're going to scroll past those questions and focus on question 23. Because question 23 is a really good question because it covers a lot of what you've learned so far, a lot. So we're going to focus first of all just on question A. Okay, so the question is, let the function f of x equal x cubed minus 3x squared minus 9x plus 11. So your domain is any real value. This is notated here. And it's a cubic function because the maximum power of x is 3. But we don't know how many stationary points it's going to have. You can kind of guess it might be 2 with a cubic, and it probably is with this one. But with a cubic, you can have a cubic that goes like this, or you can have a cubic that kind of goes like that. So you've got one stationary point for this one, and that's a stationary point of inflection, and 2 stationary points here. All right, I might just rub that out because we're going to need all the space we can get. Okay, so for question A, we're just going to sketch the graph of f of x. All right, and f of x is equal to x cubed minus 3x squared minus 9x plus 11. All right, so when we're sketching a graph, you're probably used to realizing you need to find the y-intercept, you need to find the x-intercepts, or intercept, depending on how many there are. There might be none. And now we need to also find the stationary point, or points. Okay, so we need to find all these things. Y-intercept, the x-intercepts, and the stationary points. So your y-intercept is when, well, that's a terrible, when x equals 0, your x-intercepts when y is equal to 0, and your stationary points are when your gradient is equal to 0. So we've kind of covered, well, you have done ever since probably year 9, maybe even earlier, x-intercepts and y-intercepts. We've just learned stationary points. So we're adding an extra element, but with this question, the hard part is actually finding the x-intercept. So let's go ahead and do all of them. So y-intercept is easy because it's in polynomial form. It's just going to be 11. So your y-intercept is at 0, 11. Okay, and I can read that straight from the equation. Let's go and do the x-intercepts first. So x-intercepts, let y, y equals 0. Okay, so we've got f of 0 oh, not f of 0, f of x is equal to 0. So we've got x cubed minus 3x squared minus 9x plus 11 is equal to 0. Now, we can't easily factorize that, okay? I can't take out a common factor for any of them. So what I need to use is the factor theorem. So I'm going to use the factor theorem is look at the constant term, the term at the end, and think about what the factors of that number are. So the easiest one is 1. All right, so always try 1 because 1 is going to be a factor of all numbers. And then if 1 didn't work, you could do -1 or 11, -11, but f of 1 is the easiest. Now, in class, I did say you could do this on your calculator. So see what I'm doing here. All right, so I'm just substituting in 1 for x. And you can just do that on your calculator if you like, and that's equal to 0. All right, you don't have to go expanding it. You can actually define your function, f of x, in your calculator. And I might do that towards the end to show you how to also do it on the calculator. But for your SAC, the more you do by hand, the more marks you're going to get. So, and showing you're working out, you can still do all the work like write the steps down and then just do the calculations on your calculator. That's fine. Just making sure that you show an understanding of what is actually happening. All right, so when x is 1, I get 0. So that means x minus 1 is a factor. All right, so we did cover the factor theorem in the Term 1 holidays, so make sure that you've done the work from Chapter 4. Okay, so x minus 1. To get the other factors, we divide x minus 1 into our cubic equation. So x cubed minus 3x squared minus 9x plus 11. All right, so when when you divide the function by x minus 1, you get then a quadratic, which you can find the other factors. All right, so I'll show you how to do this division. There are videos on, well, maybe one video on that I've done on YouTube. So please, if you didn't watch it before, watch it now. So what you do is how many times, x cubed divided by x is x squared. And then x squared times x gives you x cubed. And then we do x squared times negative x is negative x squared. So it's a lot of long division. So x cubed minus x cubed is 0. So you do want them equaling 0. If they don't, you've made a mistake. And then negative 3x squared minus negative x squared gives you negative 2x squared. And then we drag the negative 9x down. All right, so we're going to now do negative 2x squared divided by x gives you negative 2x. And then when I multiply that back through, I get negative 2x squared. Negative 2x times negative 1 is positive 2x. And scroll down a little bit. So we get that 0. And then negative 9x minus 2x is negative 11x, and then bring that 11 down. All right, so then we divide negative 11x by x. I'll get negative 11, and then multiplying through. There we go. And you should end up with 0 because x minus 1 is a factor. You should get 0 at the end. If you don't get 0, you've made a mistake somewhere along the line. All right, so our quadratic is x squared minus 2x minus 1. So that means at this point, I've factorized our function to be x minus, not 2, sorry, x minus 1 and x squared minus 2x. Oh, what was it? Let me just check my notes. Minus 11. All right, but that doesn't help us. That only gives us one x-intercept from the x minus 1. So we get an x-intercept at x equals 1. So we've got to factorize the x squared minus 2x minus 1. Or, so we're letting x squared minus 2x minus 11. Okay, so we can use the quadratic formula, or some of you like to cross multiply. Sorry, that's not very good. I just prefer the quadratic formula. I think we use the quadratic formula a lot in other instances, that I will always go to the quadratic formula. All right, so your value of A is coefficient of x squared, which is 1. Your value of B is negative 2, and C is negative 11. So putting them into your quadratic formula, we get x equals negative b, which is 2, plus or minus the square root. Negative 2 squared is 4, and then we've got minus 4 times 1 times 11, so it's plus 44, over 2 times a, which is 2. We get x equals 2 plus or minus the square root of 48 over 2. And this is where it's probably good to put it into your calculator, because we need to simplify the surd, so the square root of 48. So think of a perfect square that goes into 48. Now 4 does, but you want the highest perfect square, which is 16. So the square root of 48 does become 4 root 3 over 2. And hopefully I've still got, oh good, lots of room still on my page. All right, so the 2, you can divide both the 2 and the 4 root 3 by the 2 on the denominator. So you're left with 1 plus or minus 2 root 3. So your function is x minus 1, 1 plus 2 root 3, and 1 minus 2 root 3. Now leave your values exact, okay? Unless your question specifically says do it to decimal places, you leave it exact. It's okay to put on your calculator and think, oh, for graphing, where would this point go? But even on when you're graphing, put the points on as these. All right, so that means your x-intercepts are at 1, 0. Oh gosh, sorry, I didn't do that. I just wrote the number, I didn't. Sorry, just give me 1 sec. X. Okay, so we've got 1x coordinate at 1. Oh, my son's very noisy. 2, 3. Oh gosh, I'm not thinking. So you probably can't hear him, but he's really distracting me. 0 and 1 minus 2 root 3, 0. So this is giving us the x values when y is equal to 0. I'm just making sure that I've put my factors in correctly. I'm pretty sure I have. All right, so we've got our x-intercepts there. So I'm going to put a little square around them, because when we've got a lot of working out, it's a good idea to, you've got a lot of working there, which is great, but always put a square around the important parts. All right, so there's your y-intercept. All right, so the next thing we need to do are the stationary points. Okay, so we've got the y-intercept, got the x-intercepts, and now let's find the stationary points. All right, so to get the stationary points, we do need to find the derivative. So dy dx or f dash x, however you want to write it. I'm just going to stick with dy dx because that's what I wrote up here. So your derivative of x cubed is 3x squared. Then negative 3x squared becomes, what's that? 6x. And then minus 9. All right, so there's your gradient function. So we want to let that equal 0. So dy dx is equal to 0 for your stationary point. So 3x squared minus 6x minus 9 equals 0. Now you can take 3 out as a common factor, which is lovely. So we're left with now just x squared minus 2x minus 3 equals 0. And that is easily factorized, which is great. We don't have to use the quadratic formula, but you can if you want to. So two numbers that multiply give you negative 3 and add to give you negative 2. So they're going to be negative 3 and 1. So we have stationary points at x equals 3 and x equals 1. Sorry, negative 1. All right, so we've got to get the corresponding y values. So to get your corresponding y values, you substitute in f of 3 back into your original function. So remember your original function here, not your derivative. All right, because with this point, your stationary point is on your curve, not on the gradient curve. All right, so when we substitute that in, and I don't have that in my notes, so I'm just going to do it as I go. So we've got 3 cubed minus 3 times 3 squared minus 9 times 3 plus 11. So what we're just getting here is the y coordinate of the stationary point. So 3 cubed is 27. Obviously, you can do this on your calculator, but I don't have a calculator on me. So 3 squared is 9 minus 27. 9 times 3 minus 27 plus 11. Okay, so that's going to be negative 16. So our first one is at 3. Negative 16. Just looking at my notes to see if I did write it, but I don't have it on there. Okay, so let's do f of negative 1. So just substituting in negative 1, so negative 1 cubed minus 3 times negative 1 squared minus 9 times negative 1 plus 11. All right, so negative 1 cubed is negative 1. Negative 1 squared is 1, so I'm just going to be left with minus 3 plus 9 plus 11. So what's that? 2016. So, whoops, don't need that. Okay, so the other stationary point is negative 116. All right, so now we have to do the types of stationary points. So we've got the two stationary points here. So I'm going to put a square around them. They're important. Okay, so we have to test each one out, and I might just test it on the side here. So remember when we're testing, we know that we have a stationary point at 3. So your gradient is 0. So we want to know what is happening either side of 3. And we also want to know what is happening either side of negative 1. Okay, so the gradient at negative 1 and 3 is 0. So this is a straight line indicating a 0 gradient. It's not a negative sign. Okay, so just make sure that you don't think it's a negative sign. It's a 0 gradient. All right, so we need to test each one out. So I'm just looking at my notes for now. So a number greater than -1 but less than 3 is 0. You could do 1 also, but 0 is always easier. A point less than -1 is 2. So I'm going to put 0 up here and then 4. So just make sure the points you use don't go over the stationary point. So for -1, definitely -2 is less than -1, but I wouldn't go and put 5 here because 5 is greater than our next stationary point. So 0 is a nice one. So you need a number in between the two of them. All right, so let's test it out. So because we're doing the gradient function, all right, f dash of 0. All right, so when we substitute 0 into our gradient function, where are we? 3x squared minus 6x minus 9, I'm going to get -9. And when I put in 4, now I'd probably write this if I had the room, but I don't have the room. All right, so 4 squared is 16, 3 times 16 is 48. All right, and then 4 times 6 is 24. And then 24 minus 9 is 15. God, probably shouldn't be relying on my my mental maths. Okay, so your gradient at x equals 0 is a negative number, so negative gradient. Your gradient at x equals 4 is a positive number, so positive gradient. So you can see at 316, it's going to be a local min. All right, and let's do the test of the next one. Now I already know at 0 it's negative. Okay, so let's test it at -2. All right, so substituting it back into the gradient function. So -2 squared is 4, 3 times 4 is 12. Then 6 times -2 is 12. So plus, yeah, so we've got 12 plus 12, it's 24, and that's going to give us a positive number. I think positive 15. Is that right? Doubting myself now because I got f of 4 is 15. It's probably just the numbers that were used. All right, let's just have faith in it because we just need to know whether it's positive or negative. So the values, if I'm slightly out, it's okay. We just need to know whether they're positive gradients or negative gradients. So, okay, so at -116, it's a local max. All right, so graphing. So I'm going to be a little bit of a cheat and graph it on my calculator, not my calculator, on my computer. So this isn't the one that we're doing. So I'm going to quickly write it in. So x to the power of 3 minus 3x squared minus 9x plus 11. Now remember, you can use your calculator in your SAC, so I would probably encourage you to draw it beforehand on your calculator before you actually sketch it, because you don't want to go to all the work and then realize you've done a mistake. Okay, so there's our local maximum at 116, which is what we got. Okay, remember 116, and here's our local minimum, which we can't see. It's a bit annoying, isn't it? It's just... Well, I can see there it's at 3, -16, which is good. There's our x-intercept. Oh, is that a point of inflection? I don't think so. 1, 0, and here is a our other x-intercept, which is 4.464. So they're not going to give us the exact answers on this one, but if I was to put that into my calculator, I would get that decimal answer. So let's just have a look on, actually, before we do that, let's sketch it. I don't think I can sketch it. Okay, there we go. All right, so I'm going to quickly sketch it. Just change my color. My All right, because sketching it is going to help with the next part. Okay, so we're going to put our x-intercepts in first. Okay, so we had an x-intercept at 1 minus 2 root 3 and one at 1 plus 2 root 3 and one at 1. And our y-intercept is 11. And then we had a stationary point up here. I'll fill them in a sec. And one down here. All right, and I might just do my graph in a different color. So basically make sure you go through all the important points. Oh gosh, that's terrible. But anyway. All right, and there it is. So we want to label the coordinates because for part B to E, we're going to need these points. Okay, so we've got negative 1, 16 and negative, 3, negative 16. And this point here was 1. Let's just come off. All right, and 2 root 3. Okay, so we need to use all those points for the next part. All right, hopefully you can sketch it on your calculator. Actually, what I'm just wondering whether I should do the calculator. No, let's move on. We'll do it all by hand because some people can do it on the calculator already. All right, so we've sketched the first one. We found all the points that we needed to. We've put them on the graph. Okay, so for B, C, D, and E, you don't need to go ahead and do the function, or sorry, expand. What am I doing? Substitute the value in. So for question B, we've got y equals 2 times f of x. So you just got to think about, well, what sort of transformation do we have here? So basically we're multiplying f of x by 2. So y is being multiplied by 2. So with your coordinates, you're going to have still x, but you're going to have 2y. So we have a dilation of factor 2 from the x-axis. So that's stretching our y values. So your x-intercept, sorry, we'll do the y-intercept first. It was 0, 11. So now it becomes 0, 22. Okay, so we're stretching it by 2. Your x-intercepts, so we had, let me just look at my sheet, 1, 0, and then 1 plus 2 root 3, 0, and 1 minus 2 root 3, 0. All right, so we're going to change the y coordinate. So 2 times 0 is just 0. So the y, you'll notice the y coordinate, the y coordinates stay the same. It's still 0 because 0 times anything is 0. So your x-intercepts don't change. All right, but I'm just going to write them all down anyway. All right, so they haven't changed. Now your stationary points, now I don't have them written down, but I think I can remember what they are. 3, negative 16, and what was the other one? Negative 1, 16. All right, so they now become, so the x stays the same, and negative 16 when you multiply it by 2 becomes negative 32. And then this one here, the x stays the same, and then we're multiplying the y coordinate by 2. All right, so there's all your points. You don't need to go ahead and do any expansion or anything like that, or substitution. You've got all your points there. So you can draw the same curve as we did before, but just stretch it out a bit. Or if you had to plot them on the same one, it'll be stretched. So I'm just going to get the graph up now. Just bear with me. All right, so we're going to multiply all this by 2. And we can't see the points, but let's just change our axes a bit. Actually, that's not going to be big enough. All right, so we've got that point here, which is so annoying that I can't see it when I'm, whoops, well, that might be enough. So you can see there, now it's at -32, big blue dot. There it is at +32. Our y-intercept has changed to 0.22, but our x-intercepts have not changed. Okay, so remember, you're just changing your points. If your graph is being stretched, so dilated from the x-axis, then you just draw it like that, or change your axes to match that. All right, I'm running very short on time. I'm going to take my son to basketball in a second, so I'm not going to be able to do the rest of them, but I might just talk you through them. And I know I did say I'll do the calculator, but I actually won't have time to do the calculator. All right, so for question C, we've got y equals f of x plus 2. Whoops, sorry. I just want to pause for a sec. All right, so the transformation for this one, and you should know by now, is we've had a shift to the left or in the negative direction of the x-axis 2 units. So that means your coordinates, oh, I wanted that to be black anyway. It's going to be x minus 2 and your y doesn't change. Okay, so your x coordinate now changes, but your y stays the same. So your y-intercept originally was 0, 11. Okay, and I'll just write the x-intercepts 1, 0, 1 plus 2 root 3, 0, 1 minus 2 root 3, 0, and then your stationary points 3, -16, and -1, 16. All right, so we're going to change those points. So each x coordinate is changing, but your y coordinate is staying the same. All right, so with your coordinate, so the y coordinate, now if we were to subtract 2 with that point, we're going to get -2, 11. Now remember, that's not your y-intercept, okay, that's just where that point has now moved. So if you wanted to get your new y-intercept, you just need to substitute x plus 2 into your function to get that new y-intercept, which you can easily do on your calculator. All right, let's move on to the x-intercept. So we're going to subtract 2 from each x coordinate. So 1 minus 2 is -1. Remember the y coordinate stays the same. 1 minus 2 root 3, 0 now becomes -1 plus root 2, whoops, 2 root 3, 0. And then 1 minus 2 is -1. Oh. Minus 2 root 3, 0. And I quickly do these. So that's going to be 1, -16. And this one's going to be -3, 16. All right, so you just got to think about how your x coordinate has changed. Now, because I'm extremely short on time, I am going to show you just quickly here the graph from the solutions. So you can see there your new points. They haven't labeled the x coordinate correct. It shouldn't be 1 plus 2 root 3. It should be -1 plus 2 root 3. So just take note of that. But everything else looks okay. Then with question D, we've got f of x minus 2. So this time we're moving f of x, or the graph of f of x 2 units to the right. Okay, so we can do the mapping again, but this time the x coordinate, we're adding 2 each time. And then to get the y-intercept, you can just substitute in x minus 2 into your function. And then part E, it's being reflected in the x-axis. So when you have a reflection in your x-axis, your x coordinate now becomes, sorry, if you can just go back to the original one, we've got -1, 16. So your x coordinate stays the same, but your y coordinate is now negative. Okay, so you can see there how the values have changed. Sorry to cut the video short, and I'm not going to be able to do it on the calculator, but I strongly encourage you to know how to use define on your calculator, and you can easily do it that way to check. But remember, for your SAC, you do need to be able to show all the, oops, right, I just showed you my newsletter article. You do need to know how to do it by hand. Okay, so what I've just done for A, B, and C is great. You don't have to go ahead and do all the working out for each one. The mapping of the points is how you would do B, C, D, and E. So once you've got A, then you can just map your points. All right, girls, I've got to end it there. Have a good day. Bye.